So, okay, we want to sort of talk about probability in a quantitative way, in other words, put a number on it. This is how we do it. This is the definition of how we work out probability. So it's simply the probability of an event happening is consider the number of favourable outcomes. So it's the number of outcomes that you are interested in with this event divided by the sample space. In other words, everything that can possibly happen. So, for example, what is the probability of getting a heads on a fair coin? So first of all, what is the number of favourable outcomes? What are the number of heads on a coin?
2.
How many?
2.
How many heads on a coin?
1. Oh, 1.
There's 1. What's the sample space? How many things are in the sample space? 2. There's heads or tails. Okay. So the probability of getting a heads on a coin would be 1 divided by 2, or a half. You happy with that? Yeah? What's the probability of rolling a 3 on a dice?
1 over 6.
1 over 6, because there's 1 3 on a dice, and there's 6 possible things that could happen. Now, can I just draw your attention to the way in which we write probabilities of things happening? Okay. So if you have a look at question 1, which is the probability of rolling a 4 on a fair 6-sided dice, okay, this is how you could write it. It's notation. So either you could write down probability of rolling a 4 on a 6-sided dice equals, or you can write it like this. Okay. So the P stands for probability. Then the event you're interested in goes inside the brackets. So in this case, rolling a 4. Okay. Now, can anybody tell me how many favourable outcomes are there going to be? How many favourable outcomes?
1.
There's 1. There's only 1 4 on the dice. Okay. How many are in the sample space? 6. So therefore, the probability of rolling a 4 will be 1/6. Okay. Now you notice I've chosen to give it as a fraction because that's generally how we think about outcomes. Okay. So it's the number of favourable outcomes divided by the total number of things that could happen. Okay. But how else could I give this? Percentage, good. So what would this be as a percentage? Has anybody got a calculator?
Yeah.
16.7%, I agree with that. Okay. How else could we represent this? As a decimal. So as a decimal, would you be happy this is 0.167? Yeah? So either one of these is fine. Either one of these is fine. To be honest, we do tend to not give a decimal, okay? Tend not to give a decimal, just because we prefer these two, because this thing actually has a meaning with probability, okay? There's 6 possible things that could happen, and one of them you're interested in, okay? Likewise, this actually has a bit of a meaning as well. What would this mean, 16.7%? What does that actually mean?
16.7 over 100.
Okay, so what does that mean?
What do you mean?
So what does 16.7% mean? So 16.7 out of 100, what does that mean?
There's 16 times. When it happens 100 times, 16 times is gonna like if it happens 100 times, 16 times is gonna be, I don't know how to explain, but it gets.
You're absolutely right, okay? Because percent literally means out of 100, it means if you were going to roll a dice 100 times, okay, so roll it 100 times, you would expect that 16.7 of those times would result in a 4, okay? So 16.7, so very nearly 17 times, would result in the outcome you're interested in, which is a 4. Does that make sense? Yeah? Likewise, you can also think about this in exactly the same way, okay? Because this says, instead of rolling the dice 100 times, roll it 6 times, 1 out of 6, okay? So 1 out of 6. In other words, if you were going to roll the dice 6 times, you would expect, on average, one of those times to be a 4. Yeah? Now, in reality, you know that this probably isn't going to happen. Why not? So if you roll a dice 6 times, you know in reality it's probably not going to result, one of those times is going to result in a 4. Why not?
But it's random.
It's random, exactly. Just like the laws of probability dictate, that if you have a small sample size, in other words, you only do it a small number of times, very rarely will it actually come out the number of times that you want. Okay, very, very, very rarely. But as the sample size increases, in other words, as you do it more and more times, maybe 100 times or 1,000 times or 1,000,000 times, then you start to get the outcome which you're expecting. Does that make sense? Yeah, good, excellent. Okay, so have a look at number 2 then. What is the probability of rolling an odd number? Okay, so what's the probability of rolling an odd number on a dice?
1 over 2.
Good. How did you get there?
Because there's six numbers, and,
Yep.
and the odd numbers are 3.
Yeah, exactly. 1, 3, and 5, right? So it's 3 out of 6. And of course, you can absolutely cancel that down. So you can think about this, if you like, as half of the times that you roll the dice, you should expect it to come back as an odd number. Make sense? Good, fantastic. What about the probability of it being a Friday?
1 over 7.
1 over 7, perfect. What about the probability of flipping a tails on a fair coin? 1 over 2, perfect. What about the probability of choosing a king from a pack of cards? 1 over 13, absolutely right. Okay, and if you remember the way which cards work, I wrote it on the board. Cards are split into suits. There are 4 suits. There are diamonds, hearts, they're reds, and clubs and spades, they're the blacks. Okay, and per suit there are 13 cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Okay, so because there are 4 suits and there are then going to be 4 kings in the pack, it's going to be 4 out of 52 or 1 in 13, because 1 in every 13 cards should be a king. Does that make sense? Perfect.